Good morning. So we have advanced quite a bit, and now it's time for us to discuss more complex topics. Today we are going to look at what is a loop. The concept of a loop is very important for a computer program. The loop is the central point at which the program resolves. If we don't have a loop in a program, then that program is either too simple or it hardly does anything useful. Now let's look at this problem. How can you print hello 3 times? Printf hello, printf hello, printf hello. You write this statement 3 times in your main program, and this will result in hello being printed thrice. Now how can you print hello 100 times? So if you go by the method that I have shown above, you will have to type this printf hello 100 times in the main program in order to print hello 100 times. And what happens if you want to do it 1,000 times or 10,000 times? It becomes an impossible program. The solution to this is we can use a loop. Look at the clock. This clock keeps on running. So it will be 1 o'clock, then after 12 hours it will again be 1 o'clock, after another 12 hours it will be 1 o'clock, and 1 o'clock is repeated twice every day for many days, for many weeks, many months and years and leap years, and so on and so forth. So this clock keeps on moving and moving. Similarly, a computer, as we have seen in the previous slide, the computer will execute step number 1, start from a point, execute step number 1, 2, 3, and it will end. But in a loop, it will execute step number 1, 2, 3, 4, 5, etc., and then it will go back to the first step or whatever step at which the loop is. So it keeps on repeating all these steps within the loop again and again and again. This is an infinite loop. It is very similar to the loop in which a clock runs. There is another type of loop which actually runs for a condition. So it will run for certain conditional check. For example, it will run for 100 times, and if the number of loop is 100, if it is not 100, it is true, then it is going to go back and keep on repeating until the loop becomes 100, becomes false, and it continues on its path forward. But unless and until the value is 100, the loop is executed again and again. So there is an exit condition for this loop. In the previous loop, what we have seen is there is no exit condition, the loop is infinite, but in this particular case there is an exit condition for the loop. When that exit condition is reached, the loop is terminated and the program moves forward. Let's look at the problem that we had of printing hello 100 times, and we are going to print this using a loop. Step 1 is print hello. Step 2 is go to step number 1. So if the computer is executing this, it will first print hello, go to step 2. In step 2, it is saying that go back to step 1. Again, it will print hello, come back to step 2, and keep on moving in this roundabout fashion. Step 1, step 2, step 1, step 2, step 1, step 2. Every time it goes to step 1, a hello is printed. And this is going to be an infinite loop. It will keep on printing hello forever, until and unless, of course, you choose to stop the program. Now, can we modify this to run just 100 times? Yes, there is a small program here. Integer is I. We have declared an integer variable called I, and we have assigned a value 0. At this point, please remember that when an integer value is created, its value can be anything. It can be garbage. So we have to explicitly say that its value is 0. Don't assume that once an integer value is created or integer variable is created, its value is going to be 0. You have to explicitly say that integer value I is equal to 0. So the value of this I is 0. At step 1 we increment I, and in C language this is the format of a comment, the slash and a star followed by slash and a star. So anything within this slash stars is a comment. It is ignored by the C compiler, and you can write simple English over here. Print hello. If I is less than 100, go to step 1. So this is step 1. I is incremented, hello is printed. So over here what we have is I is 0, and the program comes here, I becomes 1, hello is printed, I is 1, it is less than 100, so we go back here, I becomes 2, hello is printed, similarly I becomes 3, hello is printed, and so on. It keeps on moving until I becomes 100, and when the program reaches here, if I is less than 100, no, I is not less than 100, it is actually equal to 100, so we do not go back to step 1. And you can see this is a condition. We go to step 1 on a condition, that's why we call it a conditional thing. Now this whole thing that we have discussed in the previous slide, I have marked this with certain colors, can be represented in a slightly different way in C. Okay, let's see what's. Now the I is equal to 0. The initialization is, this is a for statement. This is I is equal to 0. Step 1, so just after the for loop, there is a step 1. This is represented by an opening brace. So anything after this opening brace is a step 1. If I is less than 100, go to step 1. So this is the condition. So this loop is going to run if this particular condition is true. Initialization, condition, and finally we have this increment. Step 1 increment. Every loop will have an initialization, it will have a terminating condition. If you do not write this terminating condition, then the loop is going to run infinitely. But if we have a terminating condition, then the loop is going to run only if this condition is true. So as long as I is less than 100, this particular statement is going to be executed. This statement, this can be one statement, can be multiple statements as well. See, this comes here, step 1 comes here, I++ comes here, printf hello comes there, the condition comes here, go to step 1. Okay, so this is go to step 1. This closing brace will result in the control going back to step 1.